Hey there, welcome back to the channel. So, today we are going to read the tutorial for LLDB. Why? Because I am tired of writing print statements every single time. Like, whenever I have to debug stuff, I have to add a lot of print statements. And okay, so this statement doesn't print, so I need to check the values of multiple different variables. So I have to add another print statements to like check the values of those variables. And then when it finally works, I have to remove those print statements again. I think a debugger is a like it might be a great tool. I haven't used a debugger like ever. I don't know GDB. I was going to use GDB for this, but a quick search told me that GDB doesn't have native support for Mac ARM architecture devices. So this is Mac. So my laptop is Mac Air M1 base variant. So uh, most of the people recommended LLDB. So that's what we are going to, you could say, read about. So let's go ahead. So this is the tutorial. You can check the URL over here. So let's go. Yeah. Okay. This document describes how to use LLDB. If you're already familiar with GDB's command set, we start with some details on LLDB command structure and syntax. Okay, I don't know GDB. I've never used it. Command structure. Unlike GDB's quite free-form commands, LLDBs are more structured. All commands are of the form noun, verb, options, option value, argument, argument. Okay. The command line passing is done before command execution. Okay, so it is the same for all commands. The command syntax for basic commands is very simple. Arguments, options, and option values are all white space and space separated. Either single and double quotes pairs are used to protect white spaces in an argument. Escape backslashes and double quotes within the argument should be escaped with a backslash. This makes LLDB's command more regular, but it also means you may have to quote some arguments in LLDB that you would not in GDB. Did not understand the thing. Like, okay, so they're talking about uh like how to give arguments and stuff, and that's fine. I don't know what we are going to do. I like I know one thing, which is like we have to set like breakpoints and stuff. Uh, but okay, we'll see. Okay, so there is one other special code character in LLDB, the backtick. If you put backticks around an argument or option value, LLDB will run the text of the value through the expression parser, and the result of the expression will be passed to the command. So for instance, if len is a local int variable with a value 5, then the command memory read dash c len, okay, will receive the value 5 for the count option rather than the string len. Okay, options can be placed anywhere in the command line, but if the argument starts with a dash, then you have to tell LLDB that you're done with sorry, my bad. That you have to tell LLDB that you're done with options for current command by adding an option termination dash dash. So for instance, if you want to launch process and give the process launch command the dash stop at entry option, yet you want the process you're about to launch to be launched with the arguments program args value, you would type process launch stop at entry. Because it starts. Okay, okay. This starts with this, so we have to end with this. So that's what we are talking about here. Yeah. If the argument begins with a then you have to tell LDB that you're done with the options. Yeah. And program arg, yeah, value. Okay, okay, fine, fine. We also try to reduce the number of special purpose argument passes, which sometimes forces the user to explicit about their intention. The first instance, you will see the breakpoint command. GDB to set a breakpoint, you might enter GDB break foo.c, and I guess this is line number, I think. Yeah, yeah. To break to break at line 12 of foo.c, and break foo to break at the function foo. As the time went on, the parser that tells foo.c 12 from foo.c foo, which means the function foo in the file foo.c got more and more complex, especially in C++. There are times where there is no way to specify the function you want to break on. Okay, the LLDB commands are more verbose but are more precise and allow for intelligent auto-completion. To set the same file and line breakpoint in LLDB, you can enter either of this. Okay, wait. Okay, so uh, okay, so this will set breakpoint inside the file foo.c at line 12. To set the same file, to set the same file and line breakpoint in LDB, you can either enter this, yeah, breakpoints dash f foo.c dash l12, yeah, sure. To set a breakpoint on a function named foo in LDB, you can enter either of this. So dash dash name will be the function name. Dash n will be the same thing. You can use the dash dash name option multiple times to make a breakpoint on a set of functions as well. This is convenient. It allows you to set common conditions or commands without having to specify them multiple times. Okay, so I can use dash name multiple times. Okay. Setting breakpoints by name is even more specialized in LDB as you can specify that you want to set a breakpoint at a function by method name. To set a breakpoint on all C++ methods called foo, sorry, named foo, you can enter either of breakpoint set method foo. Okay, on this. Yeah, sure. To set the breakpoint, Objective C selectors named align left edges. You can enter either of breakpoint set selector align left edges and then end with a colon dash s align edges. Okay, sure. You can limit any breakpoints to a specific executable image by using shlib path this for short. Okay, I'm not sure about this. What this means? You can limit any breakpoints to a specific executable image by using shlib path dash s. Yeah, I'm not sure what that does. Does it get familiar over time? What do you want to do? Yeah, it gets familiar, so it's fine. Okay, okay. Let's keep going. Let's keep going. So we are over here. The dash dash /lib option can also be repeated to specify several shared libraries. Suggestions. Okay. Suggestions on more interesting primitives of this sort are also very welcome. Just like GDB, the LLDB command interpreter. I'm audible. Yeah, 7 minutes in. That's okay. Uh, okay. Just like GDB, the LLDB command interpreter does the shortest unique string match on command names. So the following two commands will both execute the same command. Okay. Does the shortest unique string match on command names. Okay. Breakpoint set dash n. This. SKTG graphic view align edges. This. LLDB also supports command completion for source file names, symbol names, file names, etc. Completion is initiated by hitting tab. Okay. Individual options in a command can have different completers. So, for instance, in the file dash dash file path option in breakpoint completes to source files. The dash dash shlib option to currently loaded shared libraries, etc. You can even do things like if you want to specify dash dash shlib path and are completing on dash dash file path and LDB will only list source files in the shared library specified by SH. No, did not understand much of this, but okay, I get it. Then it supports like command completion. When you do with a file, it will give you like completion of the source file. Yeah, I got this. Even the SH one with shared libraries will be loaded. I don't understand like this stuff, but it's fine. Let's skip it. The individual commands are pretty extensively documented. You can use the help command to get an overview of which command are available or to obtain details about specific commands. There is also apropos, appropriate what command that will search the help text for all the commands for a particular word and dump a summary help string for each matching command. Okay. Finally, there is a mechanism to construct aliases for commonly used commands. For example, if you get annoyed typing breakpoints at file.c, yeah, sure. You can do command alias bfl. Okay, you can set aliases. So command alias asserted for BFL, breakpoint set if 1 and line 2. What does that mean though? What does this mean? Oh, okay, okay. It's like the the first word and second word. Yeah, yeah. Got it, got it. Duh. Wait, I'm so sorry. I should whatever I'm reading, it should be in the top section, but I'm forgetting it every time. Okay, let's keep it. I'll try to keep it on the top portion of the video. So LLTP has a few aliases for commonly used commands. Example: step, next, continue. But it does not try to be exhaustive because in our experience, it is more convenient to make the basic commands unique down to a letter or two, and then learn these sequences than to fill the namespace with a lot of aliases and then have to type them all the way out. If the alias abbreviation or the full alias command collides with another existing command, the command resolver will prefer to use the alias over any other command as far as there is only one alias command branch. Okay. However, users are free to customize LLDB's command set however they like, and since LLDB reads the file LLDB init at startup, you can store all your aliases there, and they will be generally available to you. Your aliases are also documented in the help command, so you can remind yourself of what you have set up. One alias of note that LLDB does include, by popular demand, is a weak emulator of GDB's break command. Okay, it does not try to do everything that GDB's break command does. For instance, it does not handle foo.c bar. Okay, this is supposed to be a function, right? So bar is a function inside foo.c, but it mostly works and makes the transition easier. Also, by popular demand, it is alias to be B if you actually want to set it. Okay, okay, got it. There is a, but it mostly works and makes the transition easier. Also, the popular demand, it is a B. If you actually want to learn the LLDB command set natively, that means it will get in the way of the rest of the breakpoint commands. Fortunately, if you do not like one of our aliases, you can easily get rid of it by running, for example, command unalias B. You can also do command alias B breakpoint. Yeah, okay. So you can run the native LLDB breakpoint command with just B. Okay, got it. So yeah, over here, yeah, let's go. The LLDB command parser also supports raw commands, where after command options are stripped off, the rest of the command string is passed uninterpreted to the command. This is convenient for commands whose arguments might be some complex expression that would be painful to backslash protect. For instance, the expression command is a raw command for obvious reasons. The help output for a command will tell you if it is raw or not, so you know what to expect. The one thing you have to watch out for is that since a raw command still can have options, if your command string has dashes in it, so to indicate there are no not option markers between the dash at the end of the command name, but before your command string. Yeah, I did not understand what I did not understand like uh, anything. What are raw commands? Oh boy, I'm starting to think that this was a bad idea, but I have to keep going. Like, okay, let's give it more try. I think it will get better. You know, like we are going to like load the program and set up breakpoints. I think the above thing is for nerds who are on like as they said, they have set it up for like people who come from GDB. So and like me, like I don't know GDB, never used it. So that's fine. I guess it will get better. So LLDB also has a built-in Python interpreter which is accessible by the script command. Okay, all the functionality of the debugger is available as classes in the Python interpreter. So the more complex commands that in GDB you will introduce with a define command, can be done by writing Python functions using LLDB Python library, then loading the scripts into the running session and accessing them in the script command. See, they are talking about like people who have already used GDB. That's fine. Okay, so let's get started. So loading a program into LLDB. We can do one thing. We can like do things side by side. How about that? Wait, 1, 2, 3, 4. Yeah, okay. So just wanted to show you something. So boom, it works. Our code. Sometimes it's even 100, which is like, so 100 means it is like the same as glibc malloc. So that's what 100 means. We are getting below 100, but that's fine. Sometimes, so let me show you. So traces, let's say you go for like fifth one. See, the fifth one gives like 227. That's like better than glibc malloc. I guess, but then I'm not sure about like I looked up like how geometric mean is calculated. So throughput is 100, which means it is similar to like you can say similar to GLibs mallocs, and utilization, which is piece utilization, is 517, which is far better than glibc mallocs utilization. But okay, and this is geometric mean, so both of them are considered for the final answer, something like that. It's a formula like uh, square root of x and y, something related to that. But okay, let's just keep going. So where were we? We were, yeah, I wanted to show you. So now you would be asking like, why did you run only the fifth one? Well, because 0 gives a segmentation fault, 1 gives a segmentation fault, 2 gives a segmentation fault, so does 3, so does 4. Well, fifth one works. Not sure why, but yeah. And if I just want to show you like the trace file. So let's say I take the zeroth file. Look at this. 5,694 commands. See, you're looking at this. This states like this file is like so big. I cannot debug, like I cannot add print statements and look at every single allocation. So hence I need GDB. Like not GDB, but any debugger. So that's why I'm needing LLDB. So let's get ahead. Like let's get into it, not ahead. So, okay, first you need to set the program to debug. As with GDB, you can start LLDB and specify the file you wish to debug on the command line, or you can specify it after the fact with file command. Okay, dot app. Okay, setting breakpoints. So do I set up like LLDB mdriver dot C? Yeah, okay. How about I set the executable? How about I set the executable? Yep, that was it. It worked, right? I think it worked. Yeah, like okay. So I can also do this LLDB and then I just tell what we are using. The current executable set to this. Cool. Um, okay. Yeah, let's get back into it. So yeah, setting breakpoints. We have discussed how to set breakpoints above. You can use help breakpoint set. Okay, help breakpoint set. Okay, so there are a lot of things. Wait. Okay, breakpoint set. I can see a lot of things and I don't understand any of them. How to clear mess mode GUI. Wait, is that a GUI version? So you do this paste GUI mode. Okay, okay, let's try this. Okay, F1. Let's how to. Oh my God, how to quit? Like, okay, I have function keys on my keyboard, but they are like assigned to tasks. Like F1 and F2 are brightness keys. Okay. The classic NeoVim struggle. How to quit NeoVim. Now I have to like type how to quit. Uh, how to quit LLDB GUI. Or I can just press Q. Is that it? Let's try everything. Oh, what did I see? Oh, it's for H. Okay, okay, okay. Oh, let me read it. So comma is so frame up, frame down, comma. Okay. So what does that mean? So return select a line, page up, page down. Okay. Frame up, frame down, page up, page down. Let's try that. Press any key to exit. No, I'm pressing comma and full stops. Nothing is working. What was the other thing? Um, frame up, frame down. Okay. So U and D. U D. Am I supposed to switch? Like I'm currently inside sources. How does this how does this work? Oh, what happened? Wait, okay. Oh, it just reversed. Okay, my bad. Hmm, no, I did quit. How though? I guess I'd be yeah, okay, okay, okay. So LLDB file is set at M driver, and then if type B, so if I went GUI and then set B, B was for breakpoint, right? So LLDB, let's say M driver, GUI, B option was for set breakpoints. Yeah, yeah. Source disassembly line. Okay, okay. So let's try B for breakpoint. So we'll see a lot of things stacked down or something. These are the values, right? 292, 908, 2060. Yep, these are the values inside um the trace file, whatever. Let's keep reading. So where were we? Okay. So setting breakpoints. We have discussed how to set breakpoints above. You can use help breakpoint set to see all the Options for breakpoints are like, for instance, you could do breakpoint set, selector, align left edges, breakpoint created, one name is equal to align left edges, location is equal to one, result equal to one. You can find out about the breakpoints you have set with breakpoint list. So, how about we use ChatGPT with this to like to learn stuff, at least learn stuff. We are not going to use it for, you can say, we are not going to use it for making a project as we discussed. So let's use it to learn it, like learn something, Uh, what is breakpoint? So from now on, only give. Wait, I think I should clear my you can say my history for ChatGPT. Just give me a minute. Yeah, you can watch my face. So let me clear. So let me clear this data controls. There's a okay, delete all chats. Yeah, should I delete all chats? Yeah, okay, fine. Yeah, gone. Kids, you can come in. Boom. So we are over here. No, we are not over here. We are over here. Yeah. So what is so yeah. From now on, for every prompt, give answer in short and informative manner. Yep, cool. Why are we updating Superman? Okay, whatever. What is a breakpoint in debuggers? Hmm. A breakpoint is a marker that pauses program execution at a specific line or function so you can inspect variable memory and program flow at that point. Cool. Okay, cool. Cool, cool. So breakpoint list, current breakpoints, one name, and answer pages is what does selector do? Let's try that. So LLDB help. Yeah, what is the selector command? What was the command like you can search for stuff? Particular word, yeah. Appropriate. Yeah, let's try that. Uh, why can't I school? Okay, you know what? Fine. Yeah, can't find it. That's fine. So setting breakpoints. Let's ask it. What does this do? What does this do? It sets a breakpoint on the objective C method. Yeah, it ends with this. Method align of edges and we will pause evaluation. What will be the command for, you can say, for C or C++? Oh, okay. So I can just give it the name. Yeah, the name thing. Yeah, yeah, cool, cool. Now, the setting a breakpoint creates a logical breakpoint which would resolve to one or more locations. For instance, break by selector would set a breakpoint on all methods that implement that selector in the classes in your program. Similarly, a file and a line breakpoint might result in multiple locations if that file and line were inlined in different places in your code. Okay, the logical breakpoint has an integer ID and its locations have an ID within the parent breakpoint. The two are joined by a dot, example one dot one in the example part. Wait, yeah, okay, so the logical breakpoint has an integer and its location have an ID with the parent breakpoint. Within the parent and breakpoint, the two joined are dot. Okay, so this is the parent, which is this, and this is the breakpoint. Is it inside this method? Is that the reason? Okay, let's try. So let's say go into LLDB. I set for a file in driver, and then I have to set a breakpoint. So inside mDriver, there is a function which is uh, breakpoint list. It doesn't mean it should be nothing. Yeah, yeah. So set a breakpoint. Yeah, breakpoint set, and let's go inside this, and then let's set for main, right? So I should give name. Yeah, okay. Main at 56, 102 line address is this. So let's try that. So and then driver dot c and me is at 77. So why do you say that you are at line 56? What is at 56? Retrace and I will mean plus 56 102. Yeah. So what is at 102? Nothing. A bunch of nothing. It must be something related to the executable. Yeah, I'm sure about that. Okay, so we set this over here, and then if we get breakpoint list, yeah, there is a breakpoint for this. Unresolved hit count equal to 1. Cool. Also, logical breakpoints remain live so that if another shared library were to be loaded that had another implementation of the aligned left edge selector, the new location would be added to breakpoint 1, except the 1.2 breakpoint will be set. Okay. The other piece of information, the breakpoint, oh, sorry, my bad. The other piece of information in the breakpoint listing is whether the breakpoint location was resolved or not. A location gets resolved when the file address it corresponds to gets loaded into the program. You're with. So okay, the other piece of information in the breakpoint listing, the other piece of information inside the breakpoint listing is whether the breakpoint location was resolved or not, which is this one. So it's saying unresolved. Okay. A location gets resolved when the file address it corresponds to gets loaded into the program you are debugging. For instance, if you set a breakpoint in a shared library that then gets unloaded, that breakpoint location will remain, but it will no longer be resolved. One other thing, so what does that mean? Oh, sure, not bad. It's a yeah, yeah. I'm like not understanding much of the stuff, so I'm getting tired a bit. But yeah, we are going to keep going. Maybe we will find, something really amazing. We'll learn something amazing. My last, you can say my last hope is that if I don't understand anything inside, like not like, okay, so I will try to go till. Oh, now that I think of it, I should read the entire thing, even if I don't understand stuff. How much is it though? Yeah, it's not much. Like it's fine. We can complete this easily. Yeah, let's read the entire thing. Yeah, it's fine. We'll do it. Yeah. Who cares? It's okay. It means unresolved breakpoint. Okay, first of all, I want you to explain. Let me give it a let me give it some context. So I am a noob. Yup. Reading about debuggers for the first time. Use simple language with example. Cool. A breakpoint is like telling the debugger stop the program here. Yep, cool. Understand it. When you start your program, the debugger looks for that line in memory. If it finds it, the breakpoint is resolved, ready to stop there. If that code isn't loaded yet, like a function in a library not used yet, you set a breakpoint in maths.c at line 10. Program loads, math.c, breakpoint resolved. What does it mean by loads? So let's say I was over here. What does it mean by loading the file? Does this mean here I loaded the driver executable file, or is it related to reaching that line using you know uh, what was it? That's fine. Let's do that. Yes, when you ran file this, you loaded the executable into LLDB, meaning LLDB now knows its codes, symbols, and memory layout, but the program hasn't started running yet, so the code sections aren't in memory. That's why your breakpoint shows unresolved. It became resolved. It will become resolved once you run the program. Run command. Run command. Developer access needs to take control of your another process for debugging continue. Okay, let me hide this then, right? Ah, okay. Yeah, okay. It didn't work. Wait, it ran, process stopped, this breakpoint 1.1. Is the service set the thing? Get OPT, mdriver stopped, mdriver was compiled with optimizations that may have been oddly, variables may not be available. Oh yeah. One thing that I missed. Okay. I think I need to insert this. Yeah. So so the thing is that our end, yeah, our make file has like it by default uses like O3 optimization somewhere. Wait, let me find. Yeah, see, it uses O3 optimization, so we have to give it a debug flag. So that will force it to use like no optimization, which is zero. So I guess this is it. So make debug. How am I supposed to give flags? Okay. If EQ, what does that mean? Okay, let's try. So make debug. If dollar $debug one blank line ends list, this C flags. Okay. Hmm. How to give flags with make. If equals. Oh, debug equal to one. Oh, okay. So this. Yep, got it. Let's go. Let's go. Got it. Got it. See, O3 optimization. But if I run make clean and I do make O3 optimization, cool. Make clean and make with debug equal to zero. Oh, oh, okay, my bad. Debug equal to one. Cool, cool, cool. LLDB and driver. Yep, and then we can set breakpoint. If we just run, yeah, okay, I allow. Oh, it stopped at it stopped inside skip block, I guess. And skip block had these two arguments. Block has this value inside it, and free pointer has this value inside it. And there was an error while doing this. That is cool. Like I can now directly see like what values are passed to skip block that it like failed. And it failed somewhere over here. So for this. So it tried to set the value of the block's previous element, the previous element's next value. So block's previous element is not equal to null. So if it's not null, then we can set its value. So blocks equal to block next. Cool. But what if block next, like what if block itself is null? Well, block that is not possible. That is simply not possible. Then why did it give an error over here? What happened, bro? What happened? Okay, we are still learning a lot of stuff. Let's just keep going ahead. We did a lot of stuff. Okay, so where were we? We were over here, right? Where were we? I haven't started drawing yet. Where is the easy code? Okay, let's keep reading. So okay, we were over here, right? The new location and the features will be added to a big point. Yeah, yeah. One other thing to note that GDP, not for GDP users, is our LLDB acts like GDP with this. pending on. Okay, which means that LLDB will always make a breakpoint from your specification, even if could not find any locations that match the specification. You can tell whether the expression was resolved or not by checking the locations field in the breakpoint list, and LLDB reports the breakpoint as pending. Okay, where you can set it. When you set it, so you can see, you can tell you've made a typo more easily. That was indeed the reason that no locations were found. It's getting boring, right? Ah, it's getting boring. Let's keep going. How many minutes in? 45 minutes in. Damn, and we haven't done anything. That is crazy. Okay, let's keep going. Let's keep going ahead. Okay, so we go over here. The other piece of information is that breaking list is whether the breaking point location was resolved or not. Location gets resolved when the file address it corresponds to gets loaded into the program you're debugging. For instance, if you set a breakpoint in the shared library, that then gets unloaded. That breakpoint location will remain, but it will no longer be resolved. One other thing to note for GDB users is that LLDB acts like GDB with this, and we go over here, which means that LLDB will always make a breakpoint for your specification, even if it could not find any location. So let's see. So what does it mean by that LLDB will always make a breakpoint for your specification, even if it could not find a location that matched your specification? Yeah, what does it mean? LLDB always creates the breakpoint even if it doesn't find matching code here. If it can't match anything, example typo in a function name or code not loaded, it marks it as pending, meaning it will activate this later and the code appears. Okay, got it. So even if you make a typo, it will be marked as unresolved, and I'll activate this later when the code appears. Resolved, matched, and active. Unresolved, pending, waiting to match again. So breakpoint set file foo.c line 12. You can delete, disable, set conditions, and ignore counts either on all the locations related by your logical breakpoint or any one of the particular locations your specification resolved to. For instance, if you wanted to add a command to delete a backtrace, when you hit this breakpoint, you could do breakpoint command add 1.1. Oh, nice. Okay, so okay. Whenever I hit a breakpoint, like I can set multiple breakpoints with this. Wait, breakpoint for the first time, it becomes 1.1. And if I set a breakpoint for the second time, then will it become 1.2 and when will it become 2.1? Good question. The first number, example 1, is a breakpoint ID, the logical breakpoint you set. The second number is a location, a specific place in the code that matches your request. Breakpoint set, name printf. If printf exists in two libraries, LDB makes 1.1, 1.2, printf in another library, sure. Both are of both are part of the breakpoint one, but different locations. If you set another breakpoint, it becomes name. Okay, 2.1. Yeah. Okay, so okay, got it. Another breakpoint. Okay, cool. Yeah. So why was there? Okay. Printf in lib system. Okay, so let me try this. So let's say I'm in over here. Yeah, if I remove this, it will be in driver and I set breakpoint for mem sbrk. Breakpoint set. Was it breakpoint set? If I do breakpoint list, there is still one call. Why is it that? What if I do this again? Show me and then 1.1 and 1.2 will be generated. So file1.c is void greet. Okay, main.c uses this. Sorry. So we compile this. So multiple functions is our. Won't we get an error for this? For redeclaration of functions because the functions have the same name. Yes, you know, normal C linking that would cause a linker error, duplicate symbol degrade because both file 1 and file 2 define a single global function. To make LDB show 1.1 without the linker errors, you can do one of these things. Shut up. To make LDB show 1.1, 1.2 without linker errors, you can do one of those. Use static, yeah, sure, and this. Okay. So if I try to set a breakpoint for something that doesn't exist, so let's say mem abcd. Yeah, okay, no breakpoint found. If I run this, what happens? Yeah, we stop it and then we run again. Run, run. Okay, breakpoint list. Hit count, we have hit it once, once. It's resolved. Oh, okay. Let's exit this. So NLDB and driver again, and let's say breakpoint set for the function mem sbrk, cool, and then let's set a breakpoint for the function what to call it, my init, right? So let's see. Let's run this. So if we first breakpoint list, so both of them are unresolved. We haven't loaded them into memory. That's cool. So if we run this, yep, we end at we return zero. Yeah. This is the init function. Yeah, okay. And now my breakpoint list should be resolved. Okay. I set one at memory is okay. It wasn't hit. How did it get resolved then? It was loaded into memory, but it was okay. But if I run this again, Yeah, I'm not getting anything. Okay, let's keep on reading. So counts either on all locations generated by the geological breakpoint or any one of the particular location to a specific location. If you wanted to add a command to print a backtrace. Yeah, okay. So I can say like whenever I reach this, I want you to run a backtrace. So this is backtrace, I guess. I hope. So let's say I exit this. Boom. Is there should be a way to clean LLDB, right? I guess we will find out like further down. So let's say I want to use like okay breakpoint set for um let's say MemSB arcade, right? Cool. Yeah. And then I look at breakpoint list. I know that's 1.1. Cool. And then I will set this like okay breakpoint command add 1.1. So I want BT the same thing, and then done means done. Okay, cool, 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 cool. And then when I reach this, there should be a backtrace. So if I run this, so I run this, boom, and I reach a backtrace. Okay, okay, okay. So a backtrace is okay, okay, okay. So you get this backtrace. Memory back increment 48, size 16, start 6076. Cool, cool. Okay, by default, the breakpoint command add command takes LLDB command line commands. You can also specify this explicit by passing the command dash dash command option using dash dash script. If you want to implement your breakpoint command using Python script instead, okay. Help break command add help break command add a set of. This is a convenient point to bring up another feature of the LLDB command help. So help add a set of commands to a breakpoint to be executed whenever the breakpoint is set. Help break command add. When you see arguments, so I can just do this. Help, let's say break. Let's add only. So I get every single thing that has break inside it. Is that it? And I get every single thing that has B inside it. Is that it? Okay, let's look for run. Okay, help break command add. So help break command. So help break command. Then I will see everything for the command. Yeah. And if I want to go more deeper, let's say add to get my charger. Okay, so if I go for add, yeah, then I get the deep, the clear explanation. Wait, how to clear screen in ability. Let's use help itself. Appropriate clear, breakpoint clear, breakpoint modify. Okay, okay, okay. Let's try that. So breakpoint clear, breakpoint list. Yeah, breakpoint clear. Combination of options. Why is that? There is supposed to be a breakpoint clear, right? Delete some disable breakpoint matching the specified source file in line. Okay, good. So breakpoint list. So breakpoint clear 1.1. No, breakpoint clear one. Okay. Settings clear, typical settings, the dictionary refresher dash 8, laser source full cache. Yep, the draws nothing how to clear the console. I know in GDB this is done with shell clear, does not control this. In the GDB case, shell clear is spawning a subshell and calling that shell is clear. One, because the shell is sharing plus internal GDB sets to clear terminal. In case of PS4, the LDB directly connected to the terminal is just video text in the PS4. Yeah, did not get the answer that I wanted. That is a no way to do this, but okay. So in short, I just can't do this. Okay, that's fine. Let's keep reading. So I understand this. So okay, cool. When you see arguments to commands specified in the syntax section, when you see arguments to commands specified in the syntax section in angle brackets like breakpoint ID, that indicates that this is some common argument type that you can get further help on from command system. So in other case, you should do this. So help breakpoint ID. Sorry, 1 or 1 minutes in. I think we should stop. We will continue reading it like in the coming things, or maybe I will read this off camera. I'm not sure because like this is pretty boring for you guys. Like the thing is that no one watches these videos, but okay. Uh, any person that does, thanks for watching this. Like thanks. I'm not sure how to use this. I guess process is something we'll be using. Oh yeah, we can also use our PID, name sketch wait for this is I mean start frame state, frame variable self. This is increment. If I run this and then I run frame variable again, we know the things that we have is increment that was passed to manage the arcade. Yes, and old BRK value. Okay, frame variable self. Yeah, okay, I will read this afterwards. Or maybe there might be a better documentation out there. I should have researched, like, okay, I should research first, like, which document do I want to read? Because I just looked at this LLDB and I looked like, okay, this looks like helpful. You know, there are commands and there's like explanation of this command. So yeah, it might be a little difficult, but it might be like okay to go by. This is like I don't understand anything. Like, okay, I understand some things like, okay, it's free variable command. Like, I don't understand it, but I understand the setting breakpoints and like, okay, in this video, what have we understood? Setting breakpoints with names. There was a part I did not read that completely though. Okay, setting breakpoints, setting breakpoint with names, getting breakpoint list, uh, adding commands to the breakpoint, like the commands that needs to be executed when we reach that breakpoint, then something related to yeah, how to use the help command, like find the command that we need, then run breakpoint list. Yeah, that is it. Not a lot of things. Okay, so I guess this is it. Thanks for watching this video. I'm Aditya Bacharni, and I'm an engineer for fun. Bye.